Hello, everyone. This is the lesson for Friday, March 26th. We're going to start a new section today, really properly get into the statistics half of the course with chapter 10.1, focusing on situations where we're trying to approximate one proportion, and we'll talk about what that means towards the end of the day today. And remember that in our previous lesson, we talked a lot about school testing. And one of the things we did was we found an interval where there was a 90% chance that a school would land, and 5% of the 5% chance the school would exceed that interval, and 5% chance they would fall below it. So what we were essentially finding there was a confidence interval of sorts. So we'll do some more examples and then talk about how that's useful in the practice of statistics and in science. So our first example, I'm going to base on the game of roulette. So roulette has, or usually has, 18 red numbers, 18 black numbers, and 2 green numbers. And people bet on a specific number or a group of numbers, or maybe even or odd, or one color or another. So suppose we bet on red. So the probability of a win in this case is 18 out of 38. So there's 38 possible numbers, and 18 of them are red. Our chances of winning are 18 out of 38. And I am going to have two parts here. Suppose that we play 30 spins of the wheel. And I figured that might be how many times you could play in an hour. I don't know exactly how long it takes for people to place their bets and the wheel to spin and the winners to be paid. But I figured that that's about 1 hour. So what is the probability that we come out ahead? So if you win, you sort of like double your money. And if you lose your money. So if you want to break even, you have to win half the time. So what is the probability we win half the time or more? So at least half the spins. I'm going to introduce some new notation here. Okay, we have probability of, and then the new thing that I'm going to do is I'm going to have P with a little sort of pointy hat on it. Windows is slow. So where's my pointy hat symbol in Windows? I think it's this one. Yes. Okay, so we're just going to call that P hat. And what that stands for is it's the proportion in our experiment. So we played, let's say greater or equal. Whoops, I hit the page down button. Okay. So P hat is the proportion from our experiment. So we did 30 spins. Some of those are going to be wins. The proportion of our 30 spins that are wins is the proportion of successes in our sample. So P hat is the sample proportion. That's what we're calling it. So P hat, this thing here, is the sample proportion. So the word sample is basically the data that you could collect from your experiment, and P hat is the proportion of successes in our sample. And we're going to repeat that, whoops, not in an equation though. We're going to repeat that with 300 spins. So let's play. Why does this keep giving me equations? Play 300 spins instead, and then play 100,000 spins. Okay, so my idea for play 300 spins is, let's say instead of playing for 1 hour, that's maybe how much you play if you sort of played all day. And I So that's 10 times. I guess I figured that that's 10 hours. That's quite a marathon. And 100,000 spin, I imagine that's the whole casino, how many times they play. So like all of the players for that whole day combined, I just estimated that as 100,000 spins. So what are the chances that you come out at least breaking even or maybe ahead, playing 30 spins, about an hour? What if you play 300 spins? That's like a whole day of playing. And what are the chances that the casino as a group, the players as a group in the whole casino come out ahead at the end of the day? Okay, so that's what we're going to work on. I think that I'll end this video here and we'll do the mini tab in a second video.